Hello, in this video I'm going to talk about inferences that you can make about an entire population based on data you get from a random sample. So again, um, an inference is a prediction or a conclusion that you make based on data or reasoning. So let's start off with an example here. Let's say a restaurant manager selects a random sample of 20 customers and records the amount they spend on their meal. Based on the sample, which is the best estimate of the average or mean amount that customers spend on a meal at that restaurant? And so here's the data. There's 20 pieces. Um, and here's the amount of money each of these customers spent. So $21, $9, $23, and so on. And so we're going to try to figure out what the average is on what people spend. So if you already know how to figure out average, pause the video and try to figure that out right now. And if you don't, just keep watching. So to figure out the average, you're going to add up all of the data values. Okay, so we call that the sum. Okay, so sum all values. And then we're going to divide that by the number of values. So if you add up all these numbers, you're going to get 320. And then you divide by the number of values. Well, the number of values are the number of entries we have. So we have 1, 2, 3, 4, 5. So we have 4 rows of 5, so 20. So all of that divided by 20 is going to equal 16. And so we can say that the average customer in this sample spends $16 on dinner. And based on that sample, you can predict that all the customers would spend an average of $16. And so if you expect 100 customers to come in that day, you would expect to earn $1,600 or something like that. Let's go on to something else here. So let's say there's 360 students in a middle school, and 3 of them are doing a survey of 25 random people. And they're asking them who they plan to vote for in student council, or for student council president. And the results are shown in the table. So here are the candidates. We have Emma, Ty, and Carlos. And here's 3 people taking a sample. And so, for instance, in Sonia's sample, 6 people said they were going to go vote for Emma, 7 said Ty, and 12 said Carlos. Okay, so using this table, we want to make a prediction on how many votes Carlos will get. Based on 360 total students. Okay, so if we look at Sonia's sample first, Carlos got 12 out of the 25 votes. Notice that each of these people surveyed 25 people, so it's always going to be out of 25. And so we could say, well, so 12 out of 25 should equal how many votes he'll get divided by the total population. So you could say 12 over 25, or the part of the people that vote. So we could say vote for Carlos over total votes, right, is going to equal 12 over 25, which we predict will equal that same percentage or same proportion based on 360. So there's a couple different ways we can do that. We can figure out what percent 12 is of 25, or we can just do cross products here. So I'm going to do cross products. So we got 12 times 360 is going to equal 25 times x. And then we can divide both sides by 25. And let's see, 25 divided by, or 360 divided by 25, what are we going to get here? I think it's going to come out to, and you can use a calculator for this, it's going to come out to approximately 173 votes. Okay. Now if we do that same thing for Jane's sample, where so for Jane's sample, we got votes for Carlos over total votes is going to be a little different. The people she surveyed said 13 out of 25. And so we think our estimation of how many votes is going to get based on only Jane's sample should get us about 187 votes. Okay, and then if you look at, so that was Jane, and then this one was Sonia. And let's try. So for Danny, his sample gave us votes for Carlos of 15 over 25. And so his estimate would give us approximately 216 votes. So remember, back at the beginning of the video I said that we're going to make a prediction or a conclusion based on data or reasoning. So notice, depending on which sample you got, the conclusions are a little bit different. And they're just a prediction, they're just an estimation, and so none of them are expected to be exactly right. But what you can do is you can essentially make an even bigger sample by combining all of these, and then you get a better estimation. So if one of them is 173, one of them is 187, and one of them is 216, what might be a good prediction on how many votes Carlos will get? Pause, and then you can resume after you think about what you're going to say. Okay, so now that we've resumed, one thing you could do is you could average 216, 187, and 173 by adding them and dividing by 3. Another thing, you could take the middle one. Well, we think it'd probably be closer to 187 because it's not on the low end and it's not on the high end. Or you could even make a comparison even more detailed. Well, 173 is 14 less than 187, but then 216 is what, 97, 207, 217 is like 29 more. So these two are closer together. This one's a little farther, so you might give more weight to the high end of 187. You might say maybe in the low 190s. Okay, and that's probably what would happen on the average. So there's a lot of different ways you could take that data and make an estimation with it. Okay, and that is going to be it for the video, and we'll do some practice on these types of problems tomorrow.